What's the smallest value you could possibly attain or get close to?
0.
That means it's bounded below by 0. Does that make sense to you? It's got to be. You answered the question yourself. If it can't be negative, then this must be bounded below by 0. This is because a sub n is always positive. Now I'm going to make a little caveat here. This is bounded above by something. Okay, it's probably bounded above by where we start. So, are you with me? If you plug in 1, what do we get when we plug in 1? We got, was it 2 or something?
2. Yeah.
We got 2. So the upper bound is 2. Now, do I care about the upper bound right now? This function is always decreasing. Sorry, this sequence is always decreasing. Always decreasing. I care that it's decreasing. Do I care about the ceiling?
No.
Do I care about the floor?
Yes.
Yeah. So I care that it's decreasing and bounded below. I would care that it would be increasing and bounded above. It's not increasing though. It's decreasing. Is it decreasing and does it have a lower bound?
Yes.
Then what do you know about the sequence? Every bounded monotonic sequence is this bounded?
Yes.
Is it monotonic?
Yes.
Don't care whether it's monotonic, increasing, or decreasing, if it's bounded appropriately. This is decreasing and bounded below. Therefore, this is convergent. Bam. Be 1, -1, 1, -1, 1, or actually -1, 1, -1, 1, -1, 1, -1, forever. Would that converge or diverge? If you give me 8, give me 8. 8 to the first, 8 to the second, 8 to the third, 8 to the fourth, what's happening? Monotonically increasing without bound. Well, that's the whole thing, right? It's got to be bounded. That would diverge. How about 1/2? 1/2 would be decreasing. It would also be positive. That would be bounded below. Monotonically decreasing and bounded below by 0. That would converge. You guys with me? About -1/2.
No. Yeah.
-1/2. Okay, this is going to be weird, but -1/2 to the n, same thing as -1 to the n times 1/2 to the n. Yes, no? Remember that whole idea that if the absolute value of the sequence converges, the sequence converges? Do you remember that whole idea about if the absolute value of the sequence converges, then the sequence converges? Booyah, converges. Okay? So here's the point. There's 2 numbers that are kind of our guidelines. 1 and -1. Anything between, do you understand that anything between there is going to get smaller? Fractions. Take fraction to a power, what happens? I don't care that it's negative, it's going to go positive. All right, we can start something completely new. We're going to start talking about Chapter 9. In Chapter 9, we talk about sequences and then series. This is a complete sidestep from all the integration techniques that you've had up to this point. We will be using them, but it's not just integral after integral after integral. That's not what we're talking about here. We're going to be talking about these 2 ideas called sequences and series in this chapter. And in the first section, we're going to limit it just to sequences. We'll talk about what a sequence is. I'll show you how to get terms from a sequence. Get a sequence in sequence notation from a series of from a sequence of terms. I'll also show you how to tell when a sequence will converge or diverge. Those 2 ideas are going to be very important for us in this chapter. Most of what we're going to be doing is testing for convergence or divergence. Whether a sequence or series goes to one number or whether it doesn't. That's in the basic sense of things. So, in section 9.1, we are going to get a very in-depth discussion of what sequences are all about. Again, I'm going to try to teach this to you because, if you're like me, you didn't get a lot of exposure to this before right now, which means that you might have seen a sequence before, but you really don't know a whole lot about them. We're going to learn a whole lot about them right now. First thing, what a sequence is. So a sequence typically denoted like this, A sub n. It's a set of terms And the set of terms is based on, well, whatever this sequence is given to you as. It's typically going to be first term, second term, third term, and we denote those as a sub 1, a sub 2, a sub 3, all the way until we get a sub n, wherever we start. N is always going to be a positive integer for us. We can't have a negative term here. So we say, hey, we have the first term, it's a sub 1. Sometimes you can do like the 0th term, a sub 0. But typically we have a sub 1, a sub 2, a sub 3, a sub 4.